Okay, so wave models is kind of just a continuation of what we've been talking about with a focus on two new experiments that prove some things. Wave models is this idea that it's also called the wave particle duality. And it's just this idea that light is both energy and a wave. And there's a lot of actual depth to that becomes very important. But what's most important is that we need to be able to talk about light as energy source and also as a wave. And now we've been doing that already, right? We did that with the EM spectrum, talk about that in a second. We did that with transverse versus longitudinal, talk about that in a second. We've actually been talking about this three different ways, but now we want to kind of appreciate how light can exist as both of these ideas we care about. The movement of the wave is going to be considered, or rather, the movement of light is when we'll consider it a wave. The energy of the wave is when we're going to consider it a particle. And so this means that we can study it as a wave. We can also study it as like a single point in space. And that's become significant and helpful in how we want to study it in a couple different ways. So quick little like review stuff. You want to remember that we talked about transverse perpendicular light. We talked about how light waves move transverse, where you have the vibration going up and down and the motion going left and right, making that perpendicular direction. We talked about reflection, we did for sound, but also for light, the idea of looking into a mirror and how we knew how light could bounce back. And then finally, next week, we'll talk about refraction, where we're going to have this idea of light bending. And so all three of these situations, right, moving perpendicular, the ability to bounce, the ability to bend, all of these are talking about light as a wave because all of these are talking about the motion of the light. We're going to find out that there's one more major experiment or major phenomenon that light goes through that relies on its motion and therefore relies on it being a wave. So here we have, transverse, reflection next week, refraction also next week, but two ideas that we'll look into much, much, much more detail. Right now, though, we have this new idea called diffraction. And so if you think about the idea where if you're standing in, say, the classroom and your friend is in the hallway, not directly in the doorway of the hallway, but they're down the hallway a little bit. Let's just say near the entrance of the library. If you were to scream as loud as you can in the room, they would be able to hear you, right? If you were to scream, them, not in your eyesight, would be able to hear you. We kind of accept this because we're like, oh yeah, well the sound would go through the door, and then after the door, it would spread out in every direction. And that's actually exactly what sound, and we'll find out light do. They go through these small spaces, and then they spread out in every direction. That's the motion of the wave. That's us talking about how it moves. Therefore, that's the motion of the light. That's how it moves, and therefore that's us looking at light as a wave. The big fancy science word we're going to use for this is diffraction. So diffraction is this idea of, the spreading of waves or the bending of waves around an object, different from refraction where it bends when it changes materials. Here you have, you yelling in the room and it goes throughout the room, but also it'll go into the hallway, but then spread in every direction. So this spreading of the waves, this spreading of the waves after they pass through that opening is what we call diffraction. This also applies to light, we'll find out, creating these diffraction patterns, more details on that in class. But really what we care about mostly here is just how can we describe the motion of the wave, or what are some properties of the that come from the motion of waves? Transverse, right? Reflection, refraction, and then this other one, diffraction. What is diffraction? Spreading out after you pass through something. That sound spreading out in the hallway after it passes through that doorway. The other way to look at waves is in terms of energy, right? The other way to look at light is in terms of energy, and so therefore treating it as a particle, right? I keep saying wave, I'm sorry. The other way to look at light is as energy or as a particle. And so for that, we want to go back to last week, right? And earlier this week where we started talking about the electromagnetic spectrum. You guys created those poster boards where you drew these things out, and we saw that radio waves were very, very safe. As you go to the other side, gamma rays had much, much, much higher energy. But this spectrum mattered because it had different wavelengths and different frequencies, but we also knew that that could connect to having different amounts of energy. We have been talking about the energy present in light or the energy present in waves also. What we're going to find out is that it's more helpful to talk about energy in the sense of light not being transverse, but just being a dot moving, a particle moving. The most significant experiment for this is the photoelectric effect. And this is basically just solar panels, but the idea for this is that we can shoot light at a metal panel, and that's what all these little dots are. They're photons. They're meant to represent light as energy, and that's why they're shown as dots and not incoming waves. And so we have these particles coming in, and the result of that is that the energy of the light in is able to cause these electrons to move. We actually do this simulation in class, which is why I think it's helpful to have here. It's kind of a connector. But I think a really helpful way to think about this is just solar panels. And you don't need to know everything about what a solar panel is, but hopefully you have an idea of what solar panels do. You put them outside, the sun shines on them, and the energy from the sun, we're able to turn into electricity. We're able to convert that energy of the sun into electrical energy. If you imagine this being the sun, these being your solar panels, that's exactly what's happening with the simulation that we'll do in class. That's also what's happening with this animation over here. And so when talking about light, there's this wave-particle duality. Wave of light is all of its motion, transverse, reflection, refraction, and diffraction, spreading out. Light as energy or light as a particle is going to be most applicable to this photoelectric effect. Light as energy, particle. Light as motion, wave.